I'm Laurie Arakaki, inventor, co-founder, and CEO of Optocyte. At Optocyte, we have developed the only device that measures oxygenation inside cells. Cell oxygenation is the key to reducing organ failure. In healthy conditions, oxygen-rich arterial blood feeds organs. Organ failure is caused by prolonged oxygen deficiency to organs, and these are the most common ways people suffer from oxygen deficiency. At Optocyte, we're going to first focus on sepsis. It's associated with 20% of deaths worldwide. It is the #1 hospital charge in the US with 270,000 deaths per year, and that doesn't include deaths from COVID. Pulse oximeters are ubiquitous in hospitals, but they do not measure oxygen deficiency to organs. The Cell O2 monitor is the only device that measures oxygen in cells where it is needed to sustain organ function. Clinicians need to know whether enough oxygen is getting to the cells to make effective treatment decisions. Our technology is based on optical spectroscopy. Spectra in the visible and near-infrared regions are measured from a muscle on the palm of the hand. Our algorithm analyzes the shape of the spectra to calculate the amount of oxygen inside the muscle cells. Here's some preliminary data we obtained from 2 swine. The animals were put into severe hemorrhagic shock by withdrawing quite a bit of blood and then were resuscitated with IV fluids. One of the animals, shown in blue, resuscitated fully and did fine. The other, shown in red, did not resuscitate fully and died 5 hours later of organ failure. The difference between surviving and not surviving was in the length of time the red swine was in shock. Approximately an hour of shock caused irreversible organ damage. A pulse oximeter was used on the same 2 animals. Pulse oximeters don't tell anything about shock or resuscitation. Here are results from 2 published studies we did. In 2 types of shock, hemorrhagic shock and septic shock, the Cell O2 monitor identified patients in mild through severe shock. Pulse oximetry readings did not differ with shock severity. These data were collected from a trauma patient in the emergency department. When doctors see their patients heading downhill, they can intervene immediately. The patient appeared to stabilize after the second fluid bolus. It's important to continuously monitor critically ill patients because they are unstable. The pulse oximeter did not decrease from normal values during this time. We have 2 potential exit points, a pre-commercial one and a conventional commercial one. In order to interest potential strategic acquirers, we need to prove the clinical value of the device. We're centering our clinical studies on sepsis because it's such a big problem. It's expensive to treat, accounting for 13% of all hospital costs, and it is prevalent. There are 49 million sepsis cases worldwide each year. We'll perform an observational study this year on early sepsis detection, and this study will form the foundation for a randomized controlled trial. The randomized controlled trial is the key to clinical adoption, as it will be designed to show that using the Cell O2 monitor will reduce organ failure in sepsis patients compared to the standard of care. In summary, we have a fairly large total addressable market for the Cell O2 monitor. It is the only device with promise to reduce organ failure, and it will provide major cost savings for hospitals. We have early proof of clinical viability, a straightforward 510(k) regulatory path, and a strong IP portfolio. We will very likely not need our own CPT code and will be reimbursed under DRG, just like pulse oximeters. We have an SBIR grant from the NIH that gives us 3 years of runway, and we believe we are an excellent early acquisition target. We are seeking investment and strategic partners. Thank you very much.